This is a brief review on derivatives for cosine and sine. So I'll make my x-axis here, and I'll make my y-axis here. So that's the cosine function. Now I'll draw in the sine function. That's cosine and sine, and what I've drawn is one cycle of each function. It repeats after that. For the function y equals cosine x, the derivative dy dx equals negative sine x. And looking at the graph, right at the origin, you can see that that slope of the cosine curve is 0. And at that same point, the sine curve is 0. And then when we get to this location here on the cosine curve, that's when the cosine curve slope is at a maximum, but it's negative. It's sloping downward. The sine at that same location is at its maximum value, but it's positive. That's why we've got the negative sign here. And if we continue on, the cosine curve here has that 0 slope again, and indeed the sine is 0 too. And then we come up through here, and you can see that's the steepest slope that the cosine is going to have. This time it's sloping upwards, so that slope is positive, and the derivative is positive, but the sine curve is negative. So that's why the negative sign comes in there again. And then at the end, we're right back to a 0 slope or a 0 derivative, and the sine curve is 0 again. That's an important link between sine and cosine, that one is related to the derivative of the other. And looking at y equals sine x, dy dx equals positive cosine x. And we can look at that too. At the first location here, the sine curve is sloping upwards at its maximum value. And that's where cosine is positive at its maximum value. We go up on the sine curve here. There's 0 slope on the sine curve, and indeed the cosine is 0 there. At the next location, this is the maximum downward slope for sine, and cosine is at its maximum negative value here. We get to the location where sine has a 0 slope, and cosine is 0 again. And at the last point, it's really just a repeat of the first point. And one part of my graph that I didn't label was the y range. So this is -1, and up here, it's because sine and cosine range between positive and -1. So I'm going to change this x-axis to an axis in time, t. And at this end of the cycle, at that location, that's the end of one period, and we'll call that capital T. So capital T equals the period. That's the time it takes for a cosine or a sine function to complete one cycle. Cosine and sine, the functions themselves, range between plus and -1, but we want to make it more general than that and allow for it having an amplitude. So I'm going to say that this limit up here is plus a, and this limit down here is negative a, so that the range for the cosine and sine functions vary between plus and minus a. To write that, we'd write cosine y equals a times cosine, and in the parentheses, we're going to have a function of time, but we want to make sure it completes one cycle in the period. So it's 2 pi divided by capital T times time. We can take the derivative as before, dy dt equals negative a sine 2 pi over period times time. But now we have something else. We have to take the derivative of what's inside the sine. And that's the chain rule. And in this case, it's 2 pi over period times time. And we're taking the derivative with respect to time. So it's just 2 pi over period. And I'm going to rewrite that. Dy dt equals negative 2 pi a over period t times sine 2 pi over period times time. In the same way, if we have y equals a times sine 2 pi over the period t, then we can write the derivative as dy dt positive 2 pi a over period times cosine 2 pi over period times time. At this point, it's worthwhile mentioning omega that equals 2 pi over the period, and y times cosine omega t, and that's a lowercase omega. And then the derivative dy dt equals negative omega sine omega t. I hope that helps your math.